Have you ever stood at a train station waiting for your train, looked down at the rails, and thought, why do they look like giant metal capital I's? Seriously, of all the shapes engineers could have chosen, a square? A rectangle? A thick metal bar? They somehow settled on something that looks suspiciously like a letter from the alphabet. But have you ever wondered why train tracks are I-shaped? Is it simply easier to manufacture? Did someone accidentally invent the shape and everyone copied it? Or do trains secretly refuse to drive on anything else? As amusing as those ideas are, the real reason is a masterpiece of engineering. It may look like an ordinary piece of metal, but that familiar shape hides one of the smartest design decisions in modern engineering. Here's how it earned its place beneath every train. Welcome to Past in Plain Sight. Today, we're uncovering the fascinating reason train tracks are I-shaped. We first have to think about one simple problem to understand the shape. The problem of weight. A fully loaded freight train can weigh over 10,000 tons. That's heavier than several thousand family cars combined. Now imagine balancing all that weight on two thin strips of steel. It sounds like a terrible idea. Yet trains do it every single day. But how? The answer begins with the rail itself. Although we casually call it an I-shape, engineers actually refer to it as a flanged rail with three main parts. At the top is the head, the smooth surface the train's wheels roll across. At the bottom is the foot, which spreads the enormous weight across the sleepers underneath. Between them is the thinner middle section called the web. And that thin web is where the engineering magic happens. Now, you might think, wouldn't a solid block of steel be much stronger? It certainly would. It would also be unbelievably expensive, ridiculously heavy, and completely unnecessary. Engineers discovered something fascinating long ago. When a beam bends under weight, most of the stress isn't concentrated in the middle. It's concentrated near the top and bottom. The center experiences much less force. So why waste huge amounts of steel where it contributes very little strength? Instead, they removed most of the unnecessary metal from the middle while keeping thick sections at the top and bottom. And the result was an incredibly strong rail using far less material. It's a little like carrying groceries. You don't need to carry the entire supermarket, only the useful parts. There's another way to picture it. Imagine holding a sheet of paper flat. It's floppy. Now fold it into a simple shape. Suddenly it's much stiffer. You didn't add any extra paper. You simply changed its shape. That's exactly what engineers love doing. Using geometry instead of brute force. In fact, I-shaped beams are used everywhere. Once engineers realized how efficiently the shape carried loads, it became one of the most important structural designs ever invented. Railways simply happen to be one of its most famous uses. Of course, trains don't merely sit on the rails. They move. As a train races along the track, the rails experience enormous forces. Every wheel pushes downward, sideways, forward, and backward. Over millions of journeys, those forces add up. The rail must be strong enough to survive decades of punishment without bending out of shape. That's why railway steel is specially manufactured to be incredibly hard and resistant to wear. Modern rails are so durable that some remain in service for decades before needing replacement. What's another everyday object you've looked at and thought, why is it shaped like that? Tell me in the comments. I might turn the best suggestion into a future video. If you enjoyed this video, be sure to leave a like, subscribe to Past in Plain Sight, and join us next time as we reveal another fascinating piece of history. Thanks for watching, and we'll see you in the next one.